In this video, we'll learn the Python list dictionary and the tuples. These are three frequently used data structures, and they are very convenient to use. For the Python list, it's given by this square bracket. You can see here we have a square bracket and 1, 3, 2 that defines a list with 3 entries, the 1, 3, and the 2. And the next one here, we see the B. B has the apple and the peach and cherry. That's also a list that has 3 entries. And the C here, you see we have the free, the 99 cents and 1.99, 3 values in the C, the list. And they are not of the same type. Here, the free is a string, 0.99, 1.299. Those are float numbers. In the list, it does not have to be of the same kind. That's the convenient part. In fact, not only it does not need to be the same kind, they could be very, very different. Here, the D is an example. The first entry is a single word, and the next entry is also a word, but the third entry, third item becomes another list. So we have seasonal and summer. So that's a list there as a member of a list. And we could put all of them together, A, B, C, D, together to make a new list. This one is a list of lists. If I print it, you can see it contains the 1, 3, 2, which is the A. And then the apple, peach, cherry, that's the B. And then the C is right afterward, and then the D is at the end. So you can see this box here contains A, B, C, D, all of them together. It's a list of lists, and inside of list it has more lists. It does not matter that you have multiple layers of this nesting. And beyond these different types of data in there, you could also specify an empty list. Empty list simply just use the square bracket. Like for example, to the right-hand side here, if I want to initialize an empty list, I can write A equals the square bracket, and then if I want to print the A, it will tell me it's an empty list here. For the list, when you want to access the element of that, just use this index with square bracket, such as A0, A1, and A2, and so on. Like the previous example, A0 is the first entry, A1 is the second entry, and B0 refers to apple, B1 refers to peach. Remember, in Python, the index starts with 0. So C2 here refers to the third entry in the C list. So C here we have 3 entries. The third entry, that's the C2. So you will see the 1.99 as the printed result for C2. Similarly, the D tool would contain these 2 together as a list, seasonal and summer only. The list members in the list can be changed or modified, or you can say the lists are mutable. For example, we have A being specified as 1, 3, 2, and then we want to change the first entry to from 1 to 2, we can simply write A0 equals 2. So that modifies that first entry from 1 to 2 here. So that's for the list. Sometimes especially actually when we learn the next lecture, you will learn that the strings, they are actually similar to list, but the difference is that string cannot be modified. For example, let's say I'm going to make the B equals a string, and the string is called mutable. And if I want to access that, I can use B0, that refers to the M. And if I wanted to change the B0 to another value, change it to, for example, immutable, IM rather than the M, then I will have an error. So this will lead to an error because I'm trying to modify a part of a string and that's not allowed. So you see, this M comes from the print command. So print here gives me the first character in the variable B. But when I try to modify its first entry to a different set of string, and it says that the string object does not support assignment. Okay, so we cannot modify a string, but if we have a list, we can modify the list. Like this one, A0 equals a value that will change that first entry of A. When we want to access sub-elements of a list, we use these indexes directly. And if you have multiple entries you want to access, you can use these index with the format of starting and end separated by this colon. Like K colon R means that from the case entry, including the case one, all the way until the R minus one's entry. The last one is the R minus one. This one, keep in mind, the R's entry is not included. For example, we have the A contains 4 values, 10, 20, 30, 40. And if we write 0 colon 2, that means that we want to access the first entry, which is A0, and then the next entry A1, but we're not going to have A2 because 2 here is excluded. So that's the A0 and that's the A1. When we skip the initial index, for example, 0 to 2 can also be written as a colon 2 without giving this initial index 0. That is equivalent to the 0 to 2. Similarly, if you skip the index for the end, so if you write 2 colon and without the upper bound, that means that it goes all the way to the last entry and including that last entry. So for example, here with the A, use 2 colon, 0 is here, 1 is there, 2 is here. So 2 and above, that means 30 and 40 get printed. Okay. The next one here, if you use a negative index in the list, it will take the count from the end, from the tail. For example, a -1 is the last entry here. This is the a -1, and this one is a -2. So if you wanted the 30, you can write it as a2 or a -2. See, let me try over here. Okay, first I want to change this assignment to that. It does not work. And I'm going to write my A here, or back to this A here. A, I will have the 10 and the 20 and the 30 and the 40. And then I want the A -2. Print that one. This means the counting from the end, the second entry. And I also wanted the print of A2. This means that third entry counting from the beginning. These two should give us the same. So both give us this one. Okay, so that's the index for a list. Positive index means counting from the front. Negative index counting from the end. Again, keep it in mind that the end index, that's the one that's not being included unless you skip. If you skip, that end index here is included. Okay, so that's for indexing a list. The number of elements in the list can be counted with this command len. Just like in R, you use the length length. Here is just len with parentheses. For example, C contains 3 values in there. And if we write lenc, that'll give us the 3. Similarly, the B here, we have 1, 2, and the third value. So this is one single value, treated as one single value, okay? It's one list. When you want the length of D, you will see it's also printed as 3 here. This quotation mark is just a string. When you print it, it will just print whatever that's in the quotation mark. Either single quotation or double quotation that gives the same, treated as the same. So that's the length. This length of a list could be used for in the for loop. For example, if you use the length of D, that's actually 3, right? For this 3, you can use the range with parentheses 3 to generate this 0, 1, 2. Like in this for loop, for I in the range of this is the 3, and we wanted to print the CI and the DI together next to each other. So when I is 0, it printed the C0, which is free, and the D0. D0 is promotion, so together it becomes free promotion. I equals 1, it gives 0.99, and the D1 is year round, so you see 0.99 year round. When I is equal to 2, what you get is 1.99 for the C part, and from the D, it gives the list seasonal and summer only. Okay, so that is this range. Range of 3 means 0, 1, 2. Range of 4 means 0, 1, 2, 3. Okay. So that's when you want to use those index. So in this case, I have C with I and D with I. But if I do not really need this index, I just need the member of a list. In that case, you can directly use this for loop. For example, suppose the C is the list and we want to access each member in the C. I can do for I in C and print I. Or here, member in C, print member. Now just print each of the values in this list. We can expand or append to a list. When you try to use the .append, it will add the entry to an existing list. Okay. It does not create a new list. If you use .extend, it will create the list. Sorry, it will be still the original list, but the additional members will be added as individual members. Here's an example. We have A contains the 3 members, B contains 2 members, and we use A.append, okay. Append meaning that the B will be treated as a single member. Therefore, here, this is the B, single member. And single member is added to the existing list in A. So it's appended to the existing list A, but when you do A.append, this thing itself returns nothing, but the A becomes this 1, 2 Kansas, and then in additional, the additional member there. And if you do the A.extend, again, it will return nothing, but the A itself is modified to include the members in B as individual ones, which means that each of the member in B will be added to A. Like in this case, A from the previous line command, we get the A being this one. Now the members in B include the 3 and the KS. Each one of them treated as an individual member added to the A. So now A contains these 5 entries. So that's the A.extend and A.append. Both cases, it only add or extend or append to the original list, does not create a new list, okay? If you wanted to simply just combine 2 lists together, one easy command is to use the addition. Like here, A is a list contains 1, 2 Kansas, and B is a list contains 3 KS. We can use the A plus B to get us 1, 2 Kansas, and 3 and KS together as a single list. In this aspect, the string also has a similar property. If you have one string and another string and you use the addition, it will simply put the two strings concatenated together. See, for example, I have on the right-hand side here, B is a string mutable, and A1, I'm going to make it equal to another string. The string is not. And then I want to combine the A1 and the B. What I can do is A1 plus the B, and that will put the two together, not mutable. Okay. Sometimes you have a number and you want to combine it like string. In that case, you just need to change that number to a string. For example, I have a number called, let's say the number is 10. You can do str10 and then plus the A1 and B. So in this case, it will give me 10 and the not mutable. But if you only just do the 10, 10 is the integer with string operation, that'll be wrong. Okay, so that's this addition of the list and addition with the string. When we want to build up a list, we could use these append that we just learned. And append will always put at the end of the existing list. And if you want to put it somewhere else, you can use the dot insert. By the way, in the slides, quite often I was calling it like the method, the dot insert method, the dot append method. That's because in Python, you know, this including like list itself is a object defined as in a class, and that class contains all the properties. The Python actually call those functions defined in a class as methods. So that's why sometimes in the lecture slides, I refer it as the method. Okay. So here, if we want to put at the end of a list, we use the dot append. And if we want to put it somewhere in the middle or beginning, we can use the dot insert. Here's an example that starts with an empty list. A equals the square bracket. That's an empty list. And then I use the for loop. Oh, by the way, in the for loop, this is just the index and the in, and this is the range. And afterward, you have to use this colon to indicate it's the start of the for loop. And you can have many lines in this for loop as long as all of them have the same indentation. So here's the for loop, and what I'm going to do is just modify the A by appending to it. I use A dot append to add members to the A. What do I append there? This is I multiply 2. And then I want to print this A. This print is outside of the for loop. As you see, it doesn't have the indentation, so it's the entire list. That means that after I finish, I goes from 0, 1, 2, 3, finish all of those, then this A is being printed. So when I is 0, this A becomes just the 0 times 2. I equals 1, A becomes the 2 entries, the 0 and the 2. When I equals 2, A becomes the list with 3 entries. And then when I equals 3 is the list with the 4 entries. And when we print A, it printed all of that. Now, with this A here, if we want to insert a value at the beginning of the list, then we can put, to put at the beginning of the list, we can use the dot insert and the location and the value. This part is the location where we want to put it. And if we put this one 0 with the location -1, that means put the 0 at the end. So originally we have the 0246 and put a 0 at the end, it will become like that, the 02460. Oh, sorry. So the end here, I'm sorry, the end here refers to the 0, 1, 2, 3 refers to the index value being 3. So at the 3, index 3, it will be switched to 0. So here it will become the 0 over here. So that was the end. Originally, that was to put it's to insert, okay? If you want to put after the 6, you use dot append. So that's this insert there. And then the next one, let's consider insert at location of 0 and a -2, which means put at the beginning. So in this case, the beginning, we put a -2 there. Again, this dot insert, it will modify the original list, like a dot insert, modify the a, okay? And the a dot insert itself will returns nothing. Let me show you here. So we have this a here, and I want to print a dot insert. And what do I want to insert? I wanted to insert at position 1, and the value is -2, position 1, -2. And unfortunately, it's not going to work because this will have nothing, because a dot inserted returns nothing. Instead, if you want to print a, it will become the new one. So print the a. So that's before the insert. And if we run this one, print a again. So in this case, the first print command will give us the 10, 20, 30, 40. And when we run the second command, we'll have nothing. It will return a none. But the a dot insert is executed inside of there. And then when we try to print a again, we will get a different value compared to the original a. So that was the original one. And the a dot insert command itself returns nothing, so you see none. But because this command is being executed, it changed the original list a. And what is changed is that at location index 1, the value becomes -2. So you see here's a -2 there. So that's this dot insert. It changes the original list. We can also check if something is inside a list or is not in a list. Simply use the in and the not in. This is just like a logical check. For example, here A equals a list with 2 entries, the good morning and the hello. And if we write hi, that's a string. And then this part is to check whether hi is in this list. Hi in A, it will check each entries inside of the list A and see whether it's equal to the hi or not. So in this example, I don't have hi, so return the false. And if we put hello in A, it will return true because hello is in there. On the other hand, good morning with the lowercase g, it will return also false because the good is in the lowercase rather than capital case. And the good in A or not is also going to be false because we have good morning as one string rather than the good itself. The next one is the good morning entire string, and you see the return is the true. And the good not in A, this not in is correct because we have good morning rather than the good, so it's a true. So that's the in and the not in. So I've mentioned that we have all these different attributes, and they were also referred as methods for a list. We can use the dir to see the list. Like this example, I have the A here. If I want to see what's available for that list, I can use the dir. And with A, it will show me the available attributes. again, it will include all these built-in ones that start with the double underscore, and also these that we use them as function, like dot append, dot clear, dot copy, dot count, and so on. We have seen a few of them, and we'll see more in the next slide. So what are these things doing? We learned append is to put extra things at the end. A clear will basically just get rid of all of the members in the list. Copy will just return a copy of the original list. The count will, when you provide a value, it will count how many times that value exists in the list. And extend will try to take out the member from the second one and put it into the first list, one member at a time. And this index is just to tell what's the position of the value that you want the index for. We already know the insert is to add value to a location. And this dot pop will take out an entry from a list and also delete that entry from that list. Dot remove will simply just remove the entry from a list and returns the original list without that entry. The reverse will simply reverse the order of the members in the list. And the sort here will change the original list in the sorted, becomes sorted list. So those are the methods. And let me delete that. And I want to see, for example, in this case, I have 10, 20, 30, 40. Let's change it rather than, I'm going to change it to 10 and 2 so that when you see the sort, you will see, okay. Let's see, the first one is a.sort. What will happen, do you think, what will be printed out of this one? Oops. The pound or comment out the next two, okay. A.sort, it will change the original list A, but A.sort itself will return nothing. So you see the none, it doesn't give anything. If you wanted the A to be sorted, then you would do the, I'm going to put a new one here. You can do this sorted A, and that will not change the original A. So this sorted A is increasing order 2, 10, and 30, 40, increasing order without changing the original. Because if you try to print the original A, it will still be the 10 and the 2. So let me first print the sorted version and print the original one. This was okay, that was the A contains oh, unfortunately, because previously I had already had this A.sort. A.sort modifies the A, so it changed the A to be the sorted. If I do not want to change that, that's why I use the sorted. So let's comment that out and rerun this one. My A should become just the, if I run this line, you see the A is still the 10 and the 2, 30, 40 original list. But the sorted A is in the increasing order, okay? So that's the sort and the sorted. Beyond those, let's say, suppose you wanted to see the other one, like the pop. I believe I have examples here. So here I have the example A contains the 9, 8, 6, 5, and so on. A.copy, that's just exactly the same as the A. And A.count, 6, means that the 6 here, how many times does it appear? So it returns 2 here. And the next one, the sorted A. The sorted A does not change the original A. Instead, it will give me the ordered value in A. So 5, 6, and so on. So when I print A, it still give me the original A here. Okay. A.sort here, unfortunately, will return nothing, but the A now have been changed to this A.sort returns none, but the A becomes disordered because of a.sort being executed. The next one, a-remove 7, that will take out the 7 from the original list. So if you want to print the a again, the 7 is no longer in there. And the next one, a.reverse, it will change the order. So start from the back, 9, 8, 6, and being listed. Again, the a.reverse itself modifies the original list. Okay, it's not going to return anything if you use a.reverse itself. So the next one, we want the index of 8. So you do a.index and put 8 here. It will tell you where this 8 is located in the list. In this case, it gives me 1 because the 0 is the index for 9, 1 is the index for 8. And this a.pop, pop will take out the value and then delete it from the original list. So here I put a 3 here, means that I want to take out the 4th entry. So you see the 0, 1, 2, and here is that 3. And that entry is going to be popped out. So after you pop it out, and then the original A becomes just 9, 8, 6, and the 5 without that 6 there. So that's the pop 3. Okay, but the a.pop 3 will return the entry in that position. Let's see, for this example, that's print on the right hand side. We have a being 10 and 2, 30 and 40. I want to do a.pop. And what I want here is the 0 and 2. 2. Okay, if I put 2 here, that means I want this entry. And for that entry, I wanted the value of that. This a.pop, let's see, is that entry. And the A itself, if I want to print A here, print A, it should give me the 10 and the 2 without the, and 40 without the 30. So the pop give you what value is in that index and deleted from the original list. That's the examples for the list. The next one is dictionary. For the dictionary, we have a key and the value as a pair appearing together. So you have the key and the value separated by colon. These entries inside of a dictionary are not ordered. In fact, in the past, the Python 2, so before the Python 3.7, it was not ordered, and after the 3.7, it's become ordered based on the location where this entry was inserted. But it's not ordered alphabetically. Here's an example of a dictionary. For dictionary, we start with the big bracket. Here, big bracket to start the dictionary, and also use the big bracket to close to the end the dictionary. And inside of that, here, the name is a key. The key here in quotation mark, that's a key. And then the colon indicates that this is connecting the key and the value. The bob is the value of that name. So the key is name, the value is the bob. So that's for the first one. Okay. The next one here, the courses. Courses is the key, and this list is the value. So we have for this dictionary A, there are 2 entries. The first entry gives the name and Bob as the key value. And the second entry, it gives the course and the courses and the list of the courses. And if I want to take out, for example, this list, this belongs to the value of the courses, then what I can do is I can use A with square bracket courses that will take out this list. And that list, if I use dot append with 726 here, that will just add another course number into it. Okay. Let me copy this one and try to run it. Okay, so here. That's my A here, and I want the A square bracket, and you put the courses. So as you see, when I put the square bracket, you already know that it's tell me what's available. See courses. So if I want to do that, it will just tell me those courses together in the list, course numbers, okay? And if I want to operate like this thing is the list, you can use any of those attributes like dot append, dot insert, and so on to operate it. So if I want to do this dot insert, and where do I want to insert? I want to insert it at the beginning. I want to put a 713. I'm going to put 713 in there. Then this A courses will be changed to contain the 713, but this thing itself returns nothing. So if I want to look at the A with the square bracket and the courses, then it will give me the list with the 713 also in it. 713 was inserted. Okay, so that's this dictionary. We try to take out one of the value by indexing its key. This is the key for those course numbers. Okay. So here when we are learning the list, that's compare the list versus the dictionary. The dictionary, you can initialize it with a big bracket, and the list you initialize it with square bracket. And for the dictionary, you use the quotation mark and the key in the quotation mark to take out the value. And for, on the other hand, for the list, you just directly use the number index. And if you want to add additional things into an existing dictionary, like this one, it started with nothing, and you give the ID as a key, so B with this key, and you assign the value that will add the actual entry ID and the value 766 to this existing dictionary. And when you do the next one, enrolled, and you put a 24 there, that will add the 24 into as the value for enrolled. Okay, so these keys are being used here with the assigned values. And in the list, on the other hand, we use the dot append to add to the existing list. And for referencing the key of a dictionary, in these two examples, we have the values assigned to it. If you do not have values, for example, in this example, the B dictionary has ID and enrolled, but it does not have name. And if you reference the name, it will say that could not be found, a key error. But when it's not in there, you could assign a new value to it. And you can also use the get on the next slide I'll explain. It will not return error. Sometimes to be safe, you might want to just do a logical check. You can use for example, I want to check whether the name is in the key of this dictionary or not. I can just do a name in, and then I put the dictionary there. And in this case, because name is not in there, it gives me false. And here the ID in that dictionary, it will give me true. Okay, so now the next one is the get. This get will try to take out a key if it exists. If it does exist, okay, based on this key, it will take the value out. But if this does not exist, then you provide an optional value. and this will give the value of that. So here, let's see. For example, we have a dictionary B that contains these two entries, and we want to look at the name of the name here from this dictionary. So b.get name, you will get nothing, so it returns nothing because it does not exist. So back to here. Okay, so if you do the b.get name, it returns nothing. But if you wanted to give a value, now you can put that value in the second position here. So b.get with name again is Bob will be the returned value because the name does not exist in that dictionary B. So what you see now, the result is a Bob, but this Bob, even though you are using the get method to get it, but the Bob is not assigned to name. Original B, that dictionary still does not have the name. So this is still the original dictionary. Just let's go back to this collab here. I have A included the name and the courses, but I don't have the ID. And let's say in this case, suppose if I want to see A ID, it should give me error because I don't have the ID. So you see the key error. That one has key error. In order to have the error, not having the error, I can use it rather than the A.ID. So this was the wrong one, okay. And instead, let's do a correct one. Correct one would be the A.get. And then inside here, I'm going to put the ID. So in this case, I still don't have the ID, but this will return me no error. I will not have an error. And of course, it returns nothing either. If I wanted to return something when it does not exist, then you put something behind whatever you want to return. For example, when it does not exist, I'm going to just let it type not available. So this will print not available when the ID is not in there. So if I run it, I should get not available. But the A itself was not being modified. So if I look at my A here, it should still contain just the name and the courses, okay? So that's using the .get to obtain the key, the value based on the key and avoiding the error. We can also use this .get to help us to count the number of times an atom occurred for example, in the text. Here's an example. We have this text here, and we want to count each of the word, how many times that word appears in this text. In this case, this is a single one string. And in order to count the word, we will first need to split this string into based on the space. And to split that, you can do it by the A.split with parentheses. This will split the string based on white space. White space include the actual space, the tab, and the slash and new line symbol. Okay, so with this A.split, let me first copy this one and run it so that you will see how is my A going to look like. That's A here. But you see all these red colored, that's an error. Why do I have error? That's because I have a string, but the string is not closed in the same line, and it spans to the next line. In this case, what you need to do is to put the triple quotation mark and end with triple quotation mark. So now it will treat the whole thing together as a single string. Let me run it. Okay, so this A now is okay. And after this A is defined, and then the next thing you want to do is I want to do the A.split with parentheses. This will print each of the individual word as a member inside of the list. So A.split returns the individual word separated together in the list. Okay, so that's my list now. And I can go through this list, when we are working with this word, we try to create a dictionary, and if this word we have seen it, we'll make the count equal +1. And sorry, because here we see this word, so we make the count +1. And if we have not seen the word, we would just still add 1. Okay. But in order to be able to do the count adding 1, before this point, the count does not exist. So we need to use this dot get of this word to retrieve the get without having the error. So let's do that. So how do I do that? We'll try to do the for loop. And this for loop, I'm going to consider each of the word that's called the word I word. Okay. Let's use the word. For word in a dot split, that's the each of the member, going through each of the member in the list. And then I want to see this. Oh, before that, I have to initialize a list. And this list initialize because we want the count. Let's use this count equals a dictionary. So initialized. And for that, initialize the count. Let's do the count dot get, and what do we put in here is that word. For this word, if dot get returns something, that means that we already have a count. If it does not return anything, that means that this word before this point has not been counted. So we put a 0 there. So if the word does not exist, it returns a 0 before this point. And since now we see this word, so we're going to add 1 to that. This will add the 1. But this only add the 1, but it was not really given to, I mean, the count itself still does not have this word, because when you do the dot get, it's not adding this new word and its count into it. So we'll have to make the count make this count has this new key in there. So the count of the word will use this dot get. With this one, we'll get the previous count. And this is the current word that we see. So previous count is adding to, 1 is added to the previous count and assigned it to the current count. Once we finish the loop, what we get is for each of the word, the number of times it appeared will be accumulated together because of this sign. So once we finish that, let's print this count. Okay. Oops, error. Oh, I misspelled. It's a split. I left the S there. So run it again. And you see how, okay, if we look at the sentence here, it's how, that's the first word. When I see the first word, this count of how does not exist yet, but we use the dot get of that does not exist, so it returns a 0, 0 plus 1. So the count of the how is given a 1. And when I move on to the next word, many is the same. We also do this one is 0 because the count dot get of many does not exist. So we get 0, 0 plus 1 that gives us the 1 here. And keep going. And similarly for the time is 1. And the A here, at the time when we go through this A, the count of A becomes 1. And then later on, when we encounter this word A again, this count for A will be previous count of 1 in this part, plus a new count 1 being added. Okay, so when you go through all of the words at the end, all of those are added together, so we get A being counted 3 times. So that achieves the count of the word. Okay. This is using the dot get to help us to get the key as the value of a key in a dictionary without having error. Okay. If we want to return the keys alone without having to worry about all the values, instead we want all the keys, then you can directly just use dot keys here. This dot keys, it will return telling you that's the dictionary keys. But this one, it looks like a list, but it's not a list yet. Let's see. For example, in this case, my count is a dictionary, and I want the keys of that, which of the count, that keys. With parentheses, that will basically give me the unique words inside of the paragraph. And for each one of them, if I want to loop through any one of them, I cannot do it from here. Instead, if you want to do so, you have to convert it to a list, like putting list and parentheses. Then I could do that. Okay. Of course, you can use the for loop because what's returned in the count.keys, that's iterable. So you can directly use the for loop for I in count.keys, and then you can just print the I, that'll be fine. In this case, it does give me all the words. Okay. So this is the keys. And in fact, just the keys alone, even if you do that, even if you do the for loop, I in the count, without that, you will still get the same. Let me see. If we do the for loop, J in count, and print the J, let me comment this out. To comment out the entire block of code, you can use the control / button, control and / after you highlight it. So now if I run it, I should get the same. In this one, this count is the dictionary, and I do the single for loop with one variable in it that goes through the key of the dictionary. And if you want the values of the dictionary and you want to go through each one of them, then you can use the count dot values, parentheses. In this case, it's going to give me the count. So if I print it, this one is for the how, and here one is for the many, and so on. So count dot values give me the value of each of the key. And if you want both the value and the key, then you can do it by the dot atoms. So here, if I use the count dot atoms, that'll give me the key and the value together as tuple. And these tuples are listed together. So you see the how and one are in the parentheses, that's the tuple. Okay. We'll talk more about tuple after the dictionary. So that's one tuple, that's another tuple, and keep going. So we use dot atoms to get both the key and the value. And then the next one, let's say, if we want to loop through the dictionary and give us both the key and the value, then we can put the two variables in the for loop. Like this example, if we simply just add an actual variable, this actual variable, I'm going to put the key here and the J, and I'm going to print the key and the J. That'll give me, but since I wanted the count, I cannot have dot values because dot values only contain the values. I need to have the dictionary. So use this for loop, it will give me, key J in count. Oh, I forgot, I need to do the dot atoms. Okay, so the dot atoms, that'll give me the two things. One is the key, the other one is the actual value. So the key and the value. Okay, so that's about to access the loop through the dictionary. If you want both the key and the value, you use dot atoms. If you want just the values, you use the dot values. And if you want to use only the key itself in the for loop, you can use just the name of this dictionary, or otherwise you can also use the name of the dictionary with dot keys. That's the dictionary. Next part is the tuples. Tuples, oh, by the way, before I move on, dictionaries is a really efficient way of accessing the values for that key. It's so efficient that it achieves almost a similar speed as a database. Database is much faster than if you try to do it than the Python. But this dictionary it achieves with similar speed, almost like a like the database. Okay. The next one here is the tuple. Tuple is the kind that we separated with these parentheses. We put in the parentheses separated by comma. You can have multiple entries. Here, A contains 2 entries, the 1 and the OK. You could put more in there. For example, if I try to generate a tuple, A equals parentheses 1 and 2, and then the OK. So this is a tuple that contains 3 entries, and I want to print the A. You just directly print it. And if you have something that you want to do with the tuple, you can take out the members out of the tuple by using index. Like here, A square bracket 1, A square bracket 0, and so on. That will take out the corresponding member. Like this, here's the A1, is the second entry. And taking out the member is okay, but if you wanted to reassign different values to that member in the tuple, then it's not okay, because the tuple is not mutable. You cannot change it. So for this example, 1 and OK is the assigned. I can print it like here for I in A, it will print each one inside of this tuple. But if I want to say A1, make it rather than the OK, I want to make it 0, then I'm going to get an error because this is not allowed to make new assignment. So in fact, the tuple only allows to have a very limited operation to it. What are the limited operations? You can, let me see, it's on this slide. What operations are available for the tuple? So here A is the tuple, okay? And you can use dir to see what's available. Like here, if I try to do the dir to see what properties or methods are available for the tuple. Oh, sorry, dir of A. Then you could see it contains these underscore, and so on. Those are all built-in ones. And what we want is the ones here, like the count and index. Those are the only two that's available for the tuple. So one is the count, how many times a value appeared in the tuple. The other one is the index. It tells about where is the index of a value. For example, for this tuple, I want the count of the A. A itself is the tuple, but inside of the tuple, do I have any same A being nested inside of that? So A.count, with that, it returns 0 because I don't have an A nested in it. A.count of 1, it will check to see how many times 1 appeared in the tuple, it returns 1. And A.count of 2, it will also give us 1. The A.index will tell me for this value, what is the index of it? This value appeared here in the second position, so the index of that is 1. The index of, if I put A.index 1, that means this entry was the index will be 0. And put OK there is the index of that is 2. Okay, so that's what's available for the tuple. Compared to the list, tuple only allows these very limited operation, tell you the index and allow you to count, but does not allow you to make any modification. Back when we learned the list here allows these append extend and sort and so on, all those operations are fine, but none of them are allowed for the tuple. Because those operations, mutable operations, are not allowed for tuples, then the tuples were built more efficiently in Python. Efficient in the sense that their address, their physical address are contiguous, so that the access to them is much faster than if you try to access a list. Because of that reason, if you have something that's alone, for example, it contains many entries and you do not need to modify its members, in that case, use the tuple rather than using a list. So temporary variables use tuples because that will be more efficient to access that. In fact, the dictionaries are even more efficient than the tuples, but if you have a lot of those, the dictionaries also becomes slow. Okay. One good thing about the tuples is that the tuples can be compared. For example, here we have a tuple that contains 3 entries. When we do the comparison, this first entry is a tuple compared to the next entry. It will try to use each individual element. Start with comparing the first element, 2 and 1, and 2. So when there are identical ones, so here 2 and this 2 identical ones, it will start to use the next one. 9.8 compared to the 9.842. So if I use the maximum, it will give me this last one. If I use MIN, it will give me this one. If I use the sorted, it will give me the smallest, middle, and so on in the sorted order. That's the sorting of the tuples. Because these tuples can be sorted and it's easy to access them, they can be used to easily modify the stuff in the items of a dictionary, because the items of a dictionary is a tuple. Here, like, okay, I did not have that. Let's see, this example, suppose I have the B being a dictionary. This dictionary contains the fruit, pear, and the price of that, and the peach and price, an apple and a banana. And for here, the atoms of it are these tuples. You see the tuples here. But if we want to sort it, we can directly use the sorted command on these tuples. So once we do the sorted, it will compare these different tuples based on the first word. And if the first word is identical, it will try to use the second one in the tuple. So here you see we have the apple, banana, peach, and pear, and that's based on increasing order here. The sorted command can also use the decreasing order. For any of those that you have not learned, if you wanted to learn, anything new, you could always search on like the Google, and it will tell you the grammar of it. Okay. So that's the sorted to sort the tuples. And let's say, for example, we have an example. We have the fruit and the price, and we want to sort it. Previously, we are sorting the tuples based on the name of the fruit. But if you want to sort based on the price, to do so, if we directly do the sorted with the items, we cannot achieve that. So instead, we need to switch the value, the price, and the fruit. Switch those two. Okay. So how do we switch that? We can first initialize this inventory. You can make it a list here. And then afterward, we use a for loop with the fruit and price going through the items of the dictionary. And now for this inventory, we're going to append the price and the fruit. Because we have the price and fruit together, since we want the price first, so we put the price here. So once we have the price here, and then what we want to do is that the sorted of the inventory this time is going to be based on the price in the increasing order. If you wanted it to be in the reverse order, do reverse equals true in the sorted command. That'll give decreasing order. Okay, so that's the sorting. For this example, we can use this sorting feature of the tuples, comparison feature of the tuples to help us to return the most frequent words in a text. For example, we have one text, and I want to see what's the top 5 most frequent words. And this example, let me see example. The example simply just contains some of these. Here's the example. Okay. Example.text contains these things. It was just a piece of stuff text that I copied out of a news. And with this, I want to see which word has the top count and which word has the second highest top count, and so on. So that's the example. And to operate that one, we'll first need to open the file. In this case, my example.txt is in the local folder. And if I'm working with the Colab, I won't be able to open that. And in order to open that, I first need to upload this file onto my Google Drive. So how do I do that? Here's my Google, and I want to access the drive. So click on these 9 dots and then click on the drive. After there, Google Drive, and then you can upload the file into a folder. In this case, let me see. I'm going to just generate a temporary folder. Flag here is to generate a folder, new folder. And this one, I'm going to call it TMP. And this TMP, I will put this example.txt onto that. Drop files here, this will upload the file onto this folder. So now you see example.txt is in the Google Drive now. So once that is in the Google Drive, we'll go back to the Colab. So for the Colab, this button will allow us to mount the drive. So here, this one is already mounted because I did it previously. Mount this one. Once it's mounted, go to my drive and you see the TMP folder. So here I have the data, right? The example.txt. And if you click on this button, you can see this available. What I want is the path. So copy path here. That's from this triple dot. You click on that and you copy the path. Okay, so that is the path of this file. And then let's come back here. I will need to paste this folder there. So that gives the path for that file. And I'm going to do the file equals open, and then the quotation mark. And close parentheses. So that's the file. This is just the file handler. And then afterward, I want to count the number of times each word appeared in this file. So basically, we have to go through the lines. We use the for loop to do that. Let me put this thing here. Okay. Count, start a dictionary, and then the for loop, the line in file that will go through each line in the file. And then the word here for each line, because it's a single string, we need to use the line that split into a single word. Okay. And then for each of the word, we get is the current count plus the new one that we see. So this accumulate as we go through the words. Okay, at the end, after finish all the lines, and within each line we count and accumulate all of them through the double for loop, what we get is the count being accumulated together. So that gives us the dictionary, and let me run it just to see what do I get. Okay, counts. So that gives me like this word appeared once, Morgan appeared once, Stanley appeared once, and so on. Okay, so that's the dictionary of the word and the count of the word. And I want the top 5 most frequent word. You don't want to just examine it because the dictionary could be very big. So instead of trying to manually check which one appeared the most frequent, what we want to do is that we'll use this comparison of the tuples to achieve that. So how do we do that? We first need to use dot items to get the tuples, right? And these dot items, so it's the counts dot items. But here, this dot items is a tuple, but unfortunately, it's in this order. It's the word first and the count second. What we need is the other order. Is the order of count comes out as the first entry and the word as the second entry. So what we can do, rather than just directly like that, we need to modify it, make a new tuple to switch the value of the two. So how do we do that? When we try to make a new tuple, what we can do is use a for loop to do so. This for loop, you can do it this way, like a for, it's the key and the value in that items. And then I will have I'm going to collect the value and the key. Okay, so together. But I need to put it somewhere. And where do I put it? I want to put the value key start as a list. I cannot do it a tuple here because the tuple in the for loop we keep adding to that. That's not allowed because tuple could not be modified. Okay, so I have to do it as a list here. And in that list, I would start to add to that by dot append. And in this dot append, I'm going to put the value first and the, okay, I need to put a tuple. Okay, this tuple is the value and the key. So this tuple will be appended to the current list. Once the for loop is over, it will give me the value and the key. So if I look at the VL and with this, that one, this give me, let's see, it's this list that contains the tuples in it. And now these tuples can be compared. Okay. Back to where I was. So I don't need to see that anymore. So I have now the tuples giving the value first and the key. I now need to sort them. And that's when in the sorting, I want the highest value goes up first. So I do sorted and then the value and the key. And then I want this reverse equals true. Oh, the true or false in Python, true has to be is a capital T R U E, and the lowercase in R is all capital, but here it's just only capital initial. And in the false, it would be capital initial F here. Let's try to do the sorted and see what we get. From the top, you see these are the most frequently appeared word. And the top 5 of them, you just need to return the first 5 of those. So how do I return the first 5? Since this is a list, let's use the square bracket from 0 up to 5. That should return the first 5 of those. So that's the first 5. Okay. So that's the example of returning the top 5 most frequent words. What we did is that we go through the file and for each line, loop through the file. For each line of it, we split it so that it becomes operating by word. And for each of the word, we count the number of times that it appeared. And this count is done by check whether this count exists or not. If it does not exist, we give 0. And if it exists, we just add 1. Use the current count, add 1. Okay, so that achieves the dictionary, give us the word and the count. And afterward, we use the for loop again to switch the word and its count so that we have the count appears first. And once we have count first and value the word second, now we as a tuple, then we can do the sorting, the sorted command on the tuple with reverse tool to give us the top most frequent words. Okay, so here what I did is the for loop here to achieve that, and this kind of for loop and is to append things into a list. This could be done by without having an explicit for loop like that. Instead, you can do it by a loop expansion. So basically here, this is how it is. You start with nothing. Okay, so let me just do it over here. Okay. I will use this value key tool that's going to be equal to a list. And this list, what do I want to put in there? It will be the tuples. And what are the stuff in the tuple? It will be the value and the key. I'm going to call key 1 because previously I have this key and VAL. I don't want to use duplicate value. So you see the underline that tells that these two do not exist because I haven't had that. So they don't exist, but I'm going to have it exist using the for loop. And the for loop is the key 1 and the value in the atoms of the counts. This is like I'm going through the loop, for loop, but this for loop will directly be listing the things in here, put them together inside of this list. So that basically creates the list here. So if I run that, what I get, this one, if I want to print that, that should give me just the list. That is like a for citadel, for wood, and so on. So that gives us the key and the value together, the value and key as a list. And then afterward, you can just do the sorted command onto that, like here, the sorted, and this is that list. And then you do the reverse equals true. Okay. So that's the end of this explanation about the tuples. So far summarize what we learned here is the list, dictionary, and the tuples. A list is immutable. You can change it, and you can easily append to it or extend it. And this list is used often. But for list of the numbers, you have, for example, let's see, I have A being a list, like it is 1, 2, 3, and 4. You cannot operate it as a vector in terms of calculation. For example, I cannot do A equals 2. For the list, in order to do the math operation, you have to element-wise operating. Oh, for this one, it seems to be okay. But what if I want to do a function of, let's say, rather than, let's see, square, can I do the square? A list is okay to do square also, no. Okay, so generally, most of the operations, these math operations, most of them does not allow to operate it as a single vector. Instead, what I mean, not a single vector, like this kind of operation, in R, it'll be just directly element-wise, but in list is not. In order to operate it, you have to do individual element and operate each individual element. After we finish this part, the next part, we're going to learn the NumPy array that would allow you to operate the entire array. Okay, that's the list. And dictionary allow us to have the key and the value pair. We can use the key to access its value. Tuples are the ones that's inside of the parentheses separated by comma. Tuples are efficient in the sense that the tuple are not mutable, are not they are stored in contiguous memory. So if you need some temporary variable and it's large, it's good to use tuple. And tuples can be compared. Okay, so that's all for this lesson.